You're probably all getting anxious about infectious diseases and your immune system, seeing as we have the start of another flu season coming our way. And so how do we get ready for it? Should we have a vaccine? What about the vaccine for the pandemic? What are we going to do? Well, part of what we can do is try to keep as healthy as we can, and also to make the appropriate steps to avoid the exposure. So we think of germs as the common name, but they're really microorganisms, and they are both helpful and they also can be harmful. In a couple chapters ago, we learned about the gut and the microorganisms and the flora in your gut. Those were important for natural immunity. And so this is a little bit more we'll respond or kind of bring that information back again. So infectious diseases can be either local or systemic. And a local infection could be like a spot on your arm, you have a cut and it gets pussy or infected. It could be in your eye, it could be in a nail bed, something along that line. Systemic infection is when it is more widespread. So perhaps you ate something, you have food poisoning, or you have a bug that influences your respiratory system, and you have a cold, you feel aches, pains, it's in your nose, it's in your chest, it's your lungs. That's more of a systemic infection. There are 4 components to the path to infection. One is you have to have a host, and the host would be you, the person who is going to be impacted. The agent is the organism, and the organism can be a fungus, a virus, a bacteria, a prion, and we have an environment, and that could be where it is living, or maybe where it is, like it might be in the soil, it might be in the water, and then of course time. And the link between all of those is that you have to have an organism, an environment, a host, and a time for an infectious disease to occur. If we have a big increase in seasonal flu on campus, it could be referred to as an epidemic. If you have a lot of students in a dorm that are impacted with the seasonal flu, it could be referred to as an epidemic. We're now in the midst of a global pandemic. When that outbreak crosses over boundaries internationally or communities, countries, in this case, we are in the midst of a global pandemic. So for an infection to happen, you need to have some sort of organism and you need a reservoir. And the chain, and this is why it's so important to wash our hands and wear a mask all the time, is the reservoir is either the water, the soil, maybe someone is sick and they are harboring that organism, they're sick and they're shedding. You've heard that expression where they're shedding virus. They're known as a reservoir. A mode of transmission might be a sneeze. It might be a person that touches their face, touches a doorknob, and if that organism can stay living, infectious, person touches that doorknob again, that's called a fomite. The doorknob would be a fomite, an inanimate object. That would be a mode of transmission. It could be kissing. It could be close contact with speaking, with someone speaking and particles as it expresses out of when they're yelling at a football game or a basketball game. Portal of exit means that that organism has to have some way of exiting, and it could be through the mouth, through the eyes, through any kind of a break in the skin. For instance, if somebody has HIV, you don't want to come in contact with any bodily fluids, and you have to have a portal of entry, and that is a way of that organism to get into the next person. And that's why we wash our hands, because why we don't touch our face, why we're discouraged from sharing glasses, uh, sharing coffee. So a way to get in could be through a cut in the skin, an orifice, an eye, a nose, a mouth. So it has to live somewhere. The organism has to be able to transmit, exit that reservoir or that host or reservoir, and then be able to get in to the next unsuspecting individual. So the chain of infection. So how do we break this chain of infection? We wash our hands, we don't touch our face, we keep our distance away from people. You can wear a mask so you don't have the spray. We keep 6 feet apart. We don't share glasses. We wipe down counters. We keep things very clean. And so that breaks those locations where that transmission, so any place where you can stop that transmission. For reservoirs, we don't want to keep standing water in the summertime, because mosquitoes will breed, and mosquitoes are going to potentially can carry equine encephalitis or Zika. So we want to dump our water. So you can change the reservoir, decrease the mode of transmission, don't touch, wash, etc. So what puts you at risk for a disease? Well, being young or old. We have a much greater risk of infection at the age of 65. We have less of a risk if we're vaccinated. So one of the things that I think students are asked is, have you had your meningitis vaccine? Have you had your chickenpox vaccine? Have you had your flu? We encourage everybody to get the flu vaccine. You're less likely to get seasonal flu if you do have that vaccination. Living in close quarters, that would be environment where you live. If it doesn't have good air handling, if you live in a very dense space, if it's not sanitary or sanitized, that's a risk factor. And also, some organisms just are really virulent. That means that they can spread very easily, very quickly. Some organisms are more difficult. They're not as pathogenic. They're not as virulent. And some organisms are very virulent. And you know that we tend to have like a common cold where if your roommate gets it, then everyone gets it. That's a virulent example of virulence. Microbes can also be beneficial because microbes are helpful for us to digest our food. It helps us to make all of that bread, yeasty bread. Yeast is partially fermentation, makes the bubbles and beer and wine. It gives us kimchi and sauerkraut. So pickles, fermented pickles, so good. So food production, those are good microbes, and those can be very, very healthy for you. Speeds down the breakdown of compost, so decomposition. Microbes break down the food scraps into soil, as the slide shows. And also, microbes have been a source of vaccinations or drugs, such as penicillin. Bacteria are, we have healthy bacteria that's in our gut, and we have bacteria all over our skin, and only a very small percentage of bacteria is harmful. And those listed include Escherichia coli, which would be from meat, fecal material, meningitis, pneumonia, tuberculosis, and your ever-loving tick-borne diseases like Lyme. Antibiotics and antibiotic resistance is important to know because antibiotics are the medications that stop only bacterial infections, not viral infections. Common cold does not respond to an antibiotic. It's only for B bacteria. Antibiotics is against bacteria. So if you don't have a bacterial infection, do not take antibiotics because the widespread demand, I need to get something, give me some antibiotics. What has happened is people will take antibiotics for be prescribed antibiotics for organisms that are not going to be responsive to them. They often don't take the antibiotics all the way through, and then you have greater resistance to antibiotics in future of the future organisms. So the organisms get kind of, well, they call them superbugs. They're resistant. So Staphylococcus aureus is one. MRSA, MRSA, MRSA. MRSA is virulent, and it's also very, very difficult to treat. So we have superbugs around us. Tuberculosis is another one, very hard to treat. So we end up getting certain diseases that are very difficult to treat because they've become adapted to insufficient antibiotic application. So use your antibiotics all the way through, even after you feel like you're feeling better. So this goes back to wash your hands, get your vaccinations, and don't take an antibiotic if you don't need it. Viruses have a different structure. They also reproduce in the host. We tend to shed viruses for a while once we get exposed. The common cold, which is a coronavirus, no cure for that. Influenza and hepatitis. There are a few different types of hepatitis. Hepatitis does affect the liver, which is the hepatic system is the liver, and it gets transmitted through either contaminated food, from changing babies' diapers that are infected, and touching your face. That happens from kids that eat contaminated food. And let's see, also drug needle exchange or sharing needles. Parasites are little organisms, little critters, protozoa, worms, ectoparasites. Ectoparasites are basically fleas and lice. They're gross. I know you probably get weirded out by that. Helminths are tiny worms. That's like swimmer's itch. And trichomoniasis is a sexually transmitted parasitic disease that spread with close person-to-person contact. Parasites are easily treated. Fungi or fungi, uh, fungus can be often that just impacts your skin or your respiratory tract, and or vaginal yeast infections would be a fungal disease, jock itch, lung infections, allergic reactions, athlete's foot, or thrush, which is a real red tongue. Very painful from what I've been told. Sometimes kids get thrush. Horses' hooves also get thrush, by the way. Prions, another infectious disease, that is a oddly folded protein particle that's associated with a few diseases that are not understood real well. Creutzfeldt-Jakob disease, Kuru, chronic wasting disease. Chronic wasting disease is found in like deer. There we go. So other diseases that are emerging, Zika, that was in the 2016 outbreak in South America. Uh, Babies were born with microcephaly or didn't live too very long. Were measles and Ebola, but Ebola is very contagious, but it is also, um, if it's caught early, you can find that people have been able to survive Ebola. So supportive therapy is only available. So how the body responds to these organisms is that the organisms have some sort of marker on the outside of their surface. So it's a cell that has markers on their surface, and their markers are known as antigens. And the antigens are uh, observed or recognized by the immune system by cells that are always out surveying. Lymphocytes always out on the lookout. So when somebody has an infection, the lymphocyte number is triggered to raise because there's work to do. So the lymphocytes will respond and increase production, and the white blood cells will increase in production because they make something called an antibody. And the antibodies are going to recognize what kind of antigen or foreign invader it is, and then turn on the immune system more fully. So an antigen is what the marker is on the invading organism. And the cells that are important with making part of the immune system are going to be lymphoid, from the lymphoid organs, the spleen, the thymus, the bone marrow. They make the leukocytes or white blood cells. And these are really two types. They're either eaters, phagocytes, sometimes called macrophages, or lymphocytes, which have a bit of memory. They are what memorize or recognize when invader has been there before, and they produce a response very quickly to eliminate that invader before it can cause illness again. So when that organism enters the body, it is eaten by a macrophage or phagocyte, and that phagocyte chews it up, breaks it up, and it takes some of that marker antigen, it recognizes as foreign, it throws a little bit of that antigen on its surface, and it's called an antigen MHC complex. What it does is basically present, here is what this antigen looks like. On this foreign invader has this bump on the outside of it. That small little bit of marker is then presented to the T cells. And the T cells will turn on or pick up that antigen or lock onto it, get really excited, and then it turns on the antibody producing cells, which are the B cells, the B lymphocytes, the ones that will ultimately make memory, and then also activate killer T cells. And what they do is they glom onto the infected cell, punch a hole in it, and kill the cell. And so then you have two ways of attacking. You can directly attack the infected cell, and you can also attack the organism by making antibodies. Also, the antibody producing cells, which are the B cells, they store a memory of what that antigen looked like, so then the next time that antigen comes into the body, it can activate very quickly. So when we're born, we have an innate immunity which lasts maybe 6 months. If you're breastfed, you get some antibodies from your mother through breast milk. That's really helpful for the first is. Once that is declining, then we need active health. The adaptive immunity is when you are when your immune system is strong, so those T cells and those B cells. And that would be if you've ever had chicken pox, your body remembers it, it kills it off, and then if you get exposed to the chicken pox again, you won't get it. So that's adaptive. So if you're sick and you get it, that's where herd immunity comes into place too. If you have enough people that have had that sickness or have created the immune response, that improves the likelihood that we won't have a pandemic or an endemic. Passive means that you get the immunity from an outside source, and that is typically from a vaccination. And that's where the annual flu vaccination, MMR when you're a kid, polio vaccination when you're a kid, hepatitis has a series, that's passive immunity. So what you can do to keep your immune system strong is, this is going to sound ridiculous, be active, eat right, manage your stress, because stress causes your immune system to be depressed. So getting enough sleep and also making sure that you're getting a good healthy diet so you can support your immune system is all important for keeping your immune system strong. And if you're kind of concerned about vaccines, we know that there is hope to be a vaccine for the Corona-19 virus probably the beginning of the year, but it's not going to be available for everyone until maybe the end of next summer, because who's going to get it first? And it's not going to be available for everyone right off the bat. So vaccines are going to be helpful. The benefits do outweigh the risks. You'll find if there are still people that believe, despite it being dispelled, vaccines are not associated with autism. And that has been dispelled over and over and over again. But there was one paper, and people still get wigged out about that. So think about what makes your immune system strong and what can hinder. And I'm sure you can figure out that it's eat poorly, don't be active, smoke, all of those normal behaviors. So as you move through this chapter, think about how you could try to pay attention to how you can be better, how you can have a healthy immune system as we go into the seasonal flu, how we can keep ourselves as healthy as possible and our immune system as healthy as possible. And with that, I will say goodbye.